Hello students, welcome once again to a series of videos on differential equation. We are back again with this series of videos, and today what we are going to do is another important note, and you can write that as note number 2. Very important part to solve questions. Okay, so these notes are all on Lipschits condition. Okay, so let's say if you have a differential equation dE, that is f of x comma y is equal to dy by dx, right, at y of x of 0 is equal to y0. Now it has a unique solution. This differential equation, it will have a unique solution. Okay, will have a unique solution that will be valid in some interval. That will be valid for some interval. Okay, about the initial point. X0. All right, now if this happens, only because of this condition this will happen. So the first condition number 1 is this: the function of x comma y is continuous. Just hold on, let's write that properly. Is continuous, right, is continuous in some domain D of xy plane, right, D of xy plane. And the second point on this is going to be this. Let's write the second point as well with green. So the second point is going to be this: the partial derivative what am I writing? Partial derivative. Okay, the partial derivative, okay, del f by del y is also continuous. Function of x and y. Continuous function of x and y in D, and x0 comma y0 be points in the domain D. You see, this condition, this part is also important, and there is one more theorem that I want to give to you. Okay, very important theorem actually. So you might want to note down this theorem. So note down this theorem. The theorem states that let f of x comma y be a continuous. Let f of x comma y be a continuous function. Okay, defined over a rectangle. Alright, rectangle say R. Alright, defined over a rectangle R, and the R is given in a set form, say, that is x comma y, okay, mod x minus x0 less than equal to a. Okay, so if we have this comma, y mod of y minus y0 less than equal to b, right, where a comma b is greater than 0 if del f by del y exists and is continuous on R. Right, then what happens? Then f of x comma y satisfies Lipschits condition. Then f of x comma y satisfies Lipschits condition. And that C doesn't look good. Condition. Okay, with respect to y in R, and the constant k will now be found in this way. So now you will be able to find the constant k by this way: the least upper bound of x comma y belonging to real number mod del y of f of x comma y. Alright, del y of f of x comma y, of course inside the mod signs. Now students, in this part we have done the second note of Lipschits condition, and also we have done a theorem on Lipschits condition, and in the next video we will do a question and we will continue on with the mathematics of this part. So thank you for watching this part. We will continue this in the next video. Bye bye.